Grum wrote. Dear Hoppy, Verpies and all. I have attached again, sorry for the repetition, one of Nick's close-ups of the power transistors. Now I still cannot fathom some of the array of components. I can see a pair of back-to-back Zener diodes across gate-to-collector. I can also see steering, anti-ring diode across emitter-collector junction. The part one can't understand is the parallel resistor diode and two capacitor array. They just seem to me to be soldered to the one leg of the emitter. Any thoughts? I have placed my gate bias and parallel diode right on my IGBT. The photo seems to show no gate bias resistor local to the transistor. Could you or anyone draw a simple schema of what you see? Also for the record, initially I did not place a filter in the pose feed to my center tap of the primary transformer. But what a difference when I finally did put one there. Much cleaner signals received on the oscilloscope. Now for Hoppy the Eagle Eye, I have watched this video several times. http://www.youtube.com/watch V equals 7C4 YM2U4. 2 questions. Do you see at all the 25-turn secondary winding on the yoke transformer? I don't. And do you see any sign of skullduggery? I don't. Cheers to all, Grum. Coil answered, Groomage. I don't know if this will help. Hoppy answered, Afternoon Grum. With regards to the video, no, I cannot see a 25-turn secondary. As for any signs of skullduggery, I'm oh yes, as I think I see a thin white cable coming from the garden, through the crack in the concrete and quickly disappearing into the concrete slab, as if it had been buried into the slab and cemented over, just behind the back RHS chair leg. See timestamps 320, 457 and 510. The other video showing the thick black coiled earth cable does not show any signs of the white cable coming through the slab. There is clearly little power available as the 3 lamps are not very bright and dim noticeably when the big spot lamp is connected. Grum answered, Good evening Hoppy and all. Many thanks for your comments, but try as I might I can't see that wire you refer to. However, I have just finished watching the video that Wesley uploaded with the translation. In that one you can clearly see the pose wire after the inverter's output FWB are going to the 25-turn secondary and the other side is going to the driver board. So my apologies to all for my previous statement. Any help with those components attached to the power transistors would be gratefully received. Cheers Grum. Nix answered, that is what I show on my correction of T1000's diagram. But none of it makes sense to me. Remember that it is 220 VDC. Grum answered, Dear Nick. It's actually 311 VDC as the 220 VAC is rectified. Even higher. But it depends on the frequency applied. The AC impedance of the transformer increases as the frequency increases, therefore the current goes down. I have attached my latest idea based upon what I saw on the video. However, putting the internal choke in parallel with the field coils may be a bad idea, but who knows with this stuff. I am still working with much lower voltage at present, 90 VDC. But hammer to stand still as the HF from the internal choke keeps on taking out my drive chips. More on the way. T1000 had a great idea of putting a high wattage 12V halogen bulb in series with my IGBT's collectors. They burn out with overcurrent, 33 pence is a lot less than £12 a pop for the transistors. Cheers Grum. Nix answered, this is what I see on the video. The rectified DC goes to the red yoke coil wire with 25 turns, and the other end of that coil looks like it's connected to the yellow wire that lead to the driver board. There is also an unknown white wire going from under the yoke, towards the air coil. Also at the rectifier a single wire goes to the drive board. A grey wire as well, but from the negative side of the battery area to the driver board. The choke is wound on what looks like white PVC pipe, with about 40 turns of insulated wire, connected to a small turning cap, and to nothing else, that I can see. If there is a liner, it does not go all the way around, and there is no slit, either. I don't know, but I feel that the trick lies in the combination of coils, especially at the yoke side, and their different combined input sources. The Hendershot coil capacitor may not even be used on the last video. Most of these replication or versions used an earth ground, and would not work without it. TK even used 2 of them, for some reason. I'm still studying the SR videos, and diagrams, as well as the forum talks they had a while back. To me that diagram I posted previously drawn by SR himself holds the key to this anomaly. Grum answered, Dear Coil. Many thanks for your very first post. And it must have appeared to you that I had ignored it. For some reason it only appeared when I came online this morning. And yes, combined with Dear Hoppy's latest post, it is of great use. Thank you, Hoppy. I can now see it is a snubber circuit, and Dear Hoppy, that info even gives the correct values of resistance and capacitance to boot. No more fried IGBTs. Well, that's the theory. Smile. Dear Nick. I think we now have a good idea of the correct primary connections. We just need to fathom the secondary side. I am hoping my new driver chips arrive today so I can put things to test. Dear MagPro T1000 does not think that this device depends upon the yoke as being the source of excess energy. I am using a pair of U-section high permeability ferrite cores as a substitute. I hope this info is of some use to you. Best wishes to all. Cheers, Grum.